Hey, we're going to break section 6 into 2 days. And I kind of learned my lesson when we were talking about area. We tried to do all of these, types of figures in one day with area, and then we ended up spreading it over like 3 days. And I think it was just kind of more than we needed to tackle in one day as far as notes goes. So this first row of information is what we're going to worry about today. And then tomorrow on Thursday, we'll worry about this row right down here where we got shapes that have only one base and they're going to a vertex, going to a point. These have two bases, a top and a bottom base, a circle and a circle. See, and they have the same formula. The two right up here have the same formula. It could be any shape base. It could be a hexagon, could be a 20-sided polygon for the base, as long as it's going to an identical base on the top. Then the formula works out like this. The volume is the area of the base times the height. So that's what I want you to write down. Area of the base times the height. So I'm going to explain why it works that way. And what I'd like to try to do is kind of shade in maybe with my highlighter. Let's see if it'll let me use the highlighter here. And I'm going to highlight the top base. Okay, so this top base right here, if I could get the area of that, that's going to be the B part of the formula. Okay, so the base is the area of either the top base or the bottom base. There's a bottom base down here too. And then the height is going to be the distance between the two bases. So this right over here is going to be our height. So this B stands for area of the base. Area of base. I guess I'll put that in lowercase. And that could be this base here, right? And then the H stands for the height. Height. That's this part right over there. So I want to show you why that works. And I made a sketch on Rhino, of course. This is not the same shape of either one of these, right? This is a square base or rectangular base. This is a circular base. This one over here is a regular hexagon, right? But there's a cool command in Rhino called contour. So contour. And what you do is you select the object that you want to contour, this guy right here. And then it says select the plane base here. So let's say we get the base down here. And then it says we want to go perpendicular to what? I want to come straight up the side. And I want it to cut our figure into as many layers as it takes, going 1 centimeter at a time. So let me zoom out for a second. This guy is 20 centimeters tall. So it's going to cut it into 20 layers, each of them with a 1 centimeter height. Okay, so I hit enter and it cuts that figure into almost like floors in a hotel. So if you could imagine a hotel having a hexagonal base, we just cut it into 20 floors because it's 20 tall. So I think if you counted all those up, you'd have 20 bases. Okay. Now I did that before making my video. So I drug those layers over here. And what I'm going to do is I'm just going to delete them for now because I've already got that in layer 4. So I dragged the whole thing over. And then what I did is I just highlighted the bottom layer. So let's zoom in on this guy right down here, this bottom layer. So what is the height of this layer? It's 1 centimeter tall. And then if I could figure out what the area of the hexagon is, right? So I'd find that area and I'd multiply by 1, and that'd be how many cubic, cubes would fit into that shape. Cubic centimeters would fit into that shape. So if we could do that, if we could find one floor in our hotel, if you will, then we would just multiply that by 20 because there's 20 layers, right? It's 20 tall for the height. So that's why we're figuring out the area of the base, and then we're going to multiply it by the height. So I want to try a problem with you. And I think what we're going to do is we're going to do number 3 together, okay? So number 3, because it looks a little funky here, it looks like this. And I'd like you to have your homework looking like this as well. So you make the drawing in your notebook, and you just do the best you can. Okay, I know sometimes these drawings are kind of a challenge to get down in our notebook, but it looks kind of like this right here, and they're tricking us a little bit, because remember, the bases, it's got to be two bases that are, you know, identical to each other, that they're congruent to each other. So this base up here and this base down here are identical. This base up here and this base down here are identical. But this one here, it looks to me like it's sitting on this rectangle. There's not a matching rectangle for that. So what I need to do is I need to take this triangle that's right here. That's the base right there. And then there's one in the back here. Let me see if I change colors, if this will still be okay. So I'm going to shade the one in the back green, and then the one in the front here is this yellow color. Those are my two bases. Now, in the problem, what do they tell us as far as the dimensions go for the bases? Well, this is 3 meters right here, and this is 13 meters along that side. They tell me 5 meters right here, and they give me a little right angle symbol right there. Okay, well, in a triangle, the triangle, so the area of the base, that's why I use a capital B, because I mean the area of that yellow shape. Well, it's a triangle shape, right? Like this one was a circle, so we'd use pi r squared. We'd use pi r squared on this base. We'd use length times width for this base, right? So that base would be length times width, because it's a rectangle or a square. This one is a triangle, so I need to go 1/2 the base of the triangle times height. So how am I going to do that? Let me zoom in for just a second here, and let's focus on this triangle. Okay, so I've got 1/2, and then, well, I need this piece right down here in a right triangle. That's the base. This is the height. It's the legs that are the base and the height. Well, it's a 5, 12, 13 triangle, because it's a Pythagorean triple. If you weren't here when we talked about Pythagorean triples, you just saw me magically come up with that 12. You'd be like, well, where'd that come from? I have the Pythagorean triples that we frequently use on the wall over there. I know a lot of you guys are like, hey, I've been here since day one. Yeah, you've told us about those Pythagorean triples a million times. For those people that are like, what? Let me just put a B down here for, oh boy, I better not use B. Let's put an A down there for a side of the triangle. So I'm going to go A squared plus B squared equals C squared. And we get A squared plus 25 equals 169. We subtract 25, we get A squared equals 144. I take the square root of both sides, and I get 12. That's where the 12 comes from if you're doing the long way, but it's a Pythagorean triple, whole numbers. Anyways, you put 12 in for the base of the triangle. You put 5 in for the height of the triangle. 1/2 12 is 6. 6 times 5 is 30. So we get 30 square, whatever the units are. It says meters. Yeah, I got meters on those guys. So square meters is the area of the base. Now the volume is going to be the area of the base, 30 square meters, times the height. Oh, the height, because remember, it's not really standing up like this object is really kind of standing up. Now we could rotate this, because we're dealing with Rhino. We could rotate it so that it looks like it's laying down, kind of like that, right? Um, you know what I'm saying, right? So like if I stick it like this, this is not the base of my hexagon. That's the base. So we got matching bases, right? Why wouldn't that be the base? It has matching bases here. Well, it's because it's not going parallel straight up. It's going out on the side. So the only way that this has, matching bases that are parallel over top of each other is like this, and see how the base is just being like raised up to the top base. So anyways, hopefully you see that the height is 3 going this way. Like if I stood this thing up on its base. So I'm going to put 3 meters right here, and 30 times 3 is 90. So I've got 90 cubic meters for the volume on number 3. I hope that makes sense. I hope you feel like I went slowly over how to get that 12. Most of you guys were like, yeah, I know 5, 12, 13. That was a little tricky. thanks for watching my video. We have to do these kinds of shapes today, and then we'll do the ones at the bottom of our notes tomorrow. So I'm not giving you any notes today for this stuff down here about cones and pyramids. Okay. Hey, good luck on the homework.